Hello friends, myself Rajendra Mahajan presenting my video on linear algebra. Example, prove by method of induction, prove by method of induction if capital A is invertible matrix, so is A raised to m for every positive integer, m. Moreover, A raised to m and its inverse is equals to A inverse and raised to m. Proof. Statement. If capital A is invertible matrix, for every positive integer m, and A raised to m and its inverse is A inverse and raised to m. And to prove this, we consider base case for m is equals to 1. For m is equals to 1, we get A raised to m nothing but A raised to 1 means A, and since A is invertible matrix, its inverse exists. A inverse exists, and we have also A raised to minus 1 as A raised to minus 1 or A inverse, nothing but A inverse raised to 1. Thus, statement is true for m equals to 1. Then inductive hypothesis. Assume that the statement is true for m is equals to k. For m is equals to k. For some positive integer m is equals to k. That is A raised to k and its inverse as A inverse and raised to k. We also assume that A raised to k is invertible matrix. A raised to k is invertible matrix. Then inductive step for m is equals to k plus 1. We need to prove that prove that statement is true for m is equals to k plus 1. That is a raised to k plus 1, nothing but a raised to k into a, if we split that power. Since a raised to k is invertible, this is by inductive hypothesis. And a is invertible, a given. It is given, and therefore that product of a raised to k into a is also invertible. The inverse of a raised to k plus 1 is given by a raised to k plus 1 raised to minus 1 as a raised to k into a and raised to minus 1, and by the property of that we get a raised to minus 1 into a raised to k raised to minus 1, a raised to minus 1 as it is. That a raised to k raised to minus 1 we can write down as a raised to minus 1 and raised to k. Adding the power of a raised to minus 1, we get k plus 1, a raised to minus 1 whole raised to k plus 1. Thus, the statement is true. The statement is true for m is equals to k plus 1. Then conclusion. By the principle of mathematical induction, the statement is true. For number 1, for every positive integer, m. First case, a raised to m is invertible for every positive integer. M. And second, a raised to m and raised to minus 1 as a raised to minus 1 and whole raised to m. Hence proved. Please like my video, share it, as well as subscribe to my channel, and to receive the notification please press the bell icon. Thank you. Thanks for watching.